Good morning, students. I welcome you all to Brihan Mumbai Municipal Corporation Education Department, online education for English medium. Today we are conducting online session for class 9, subject science, and the topic which I am going to teach you today is laws of motion. And in that, the subtopic which we'll learn today is force and Newton's laws of motions. This is the first session, and my name is Ms. Bushra Ahmed, and our channel nodal officer name is Mrs. Almas Hannure. So let's start with the topic Newton's laws of motion. Before going to Newton's laws of motion, first we will learn, students, what do you mean by force? Force. Now see, force itself applies what? Some push and pull. Push means what? If we will push something, अगर हम लोग किसको ढकेलते हैं, right? और pull मतलब खींचना. When we push or pull, so this push and pull require to change what? To change motion of that object, right? So that term, that phenomena is termed as what? Force. Force is nothing but what? Push and pull. Now see, student, we'll see vector. What is vector? Vector shows magnitude and direction. Magnitude and directions means what? How much amount of force is required and in which direction the force is applied. Either it is in right direction, left direction, which direction. When direction comes, vector comes into the frame. Okay. Now we will see the next one. What are the forces in the universe? There are, students, 4 forces known in the universe. Okay. Now what are the 4 forces, students? Now see, number first is electromagnetic. Electromagnetic force are what? Forces which are caused from electric and magnetic interactions. When electric field and magnetic field come into an interaction with each other, so which force come into an existence, students? Electromagnetic force. Second force in the universe is strong nuclear force. These are the very strongest force. Now see, what is this strong nuclear force responsible for? It is responsible for holding nucleus together in the atom. What does this strong nuclear force do? It is responsible for holding what? Nucleus together in the atom. These are the strongest force, acts over the shortest distance. These are what, students? These are the very strong force. Why? Because they are acts on very short distance. Third type of force which we see in the universe is gravitation force. Gravitation force are the weakest force. Why? Because they act over the longest distance. They act over a very long distance, hence they are weakest force. Then there are weak nuclear force also, students. These are responsible for radioactivity in the atoms. So in today's session, what I thought that revision is also done many times. You all know what are the important questions also. So in this session, what I supposed to do, I just want you to clear up some basic concepts, some extra knowledge, some extra information which will be helpful for you in standard 10th also, right? So today just learn some new topic, new concepts, which will be helpful for you for understanding the concept in class 9th also, and when you'll go in class 10, that is also helpful for you. So what are the, students, 4 forces known in the universe? Electromagnetic, strong nuclear forces, gravitation, and weak nuclear forces. Okay, students? Now see, types of forces. There are 2 main types of forces, contact force and field force. See, can you see the picture here? A man is in contact with a table. So when there is a physical contact with someone, so force is applied when there is a physical contact, that are termed as what? Contact forces. Field forces. Can you see an atom here? Nucleus is there. Electrons are revolving around the nucleus, right? So there is a field generated. Electron is not physically touched with nucleus, right? But it is the force is due to the field. but due to the field, nucleus is there in the atom, electrons are revolving around the nucleus. So when there is no physical contact but still the force is there, they are known as field forces. Now see, contact forces. Contact forces exist when an object from the external world touches a system and exerts a force on it. Now see, student, contact forces exist when what, students? When an object from the external world, in the bahar se, when it touch a system, when there is physical touch is there, and due to that physical touch, when some force is exerted on it, that force are termed as what, students? Contact forces. Now see, we'll see one example. Think about a book on a table. Now see, a book is lying on a table. So if you push it, you are exerting a contact force. If you push it, what? We are applying a force on it by a physical contact, means that is contact force. If you put it down, no longer interaction, so no more force from you. Now see, when there is no interaction, we are not applying any force. But now see, if you put that book on a table, right? So you are not in contact with that table, but that book is in contact with table, right? Means, but table is touching it and table is now exerting a force on it. Now when you are not applying the force, but that book is in contact with table also, so table is exerting a force on it, means they both are in contact with each other, book and table. So when there is contact in the objects, force is exerting on them, and hence that force are termed as what, student? Contact forces. Now what is field force? An object can move without something directly touching it. Now see, if some object is moving, when nothing is touching it directly, it is moving by a force without any touch. So that is termed as field force. What if you drop the book? Now see, if a book is in my hand and by mistake the book is dropped by my hand, so it falls due to gravity, right? So it is falling, but gravitational force is what? It is a field force. That force is not touching the book, but it is exerting, the field is exerting by the gravitational force. Hence, gravitational force is a field force. They affect movement without being in physical contact. Now see, this field force are what? That affect that movement without being in a physical contact. Now see the next topic, students. Can you think of other field forces? Magnetic field, electric field, nuclear forces. Now see, in magnetic field also we have seen, see students, if two magnets we are taking and we are making iron, if we are just allowing it north and south pole, so there we can see the attraction. They are pushing, they are pulling, they are attracting with each other. If there are like poles, they get attract with each other. If there's a like pole, they go apart from each other. So these are without in contact, right? Without in a physical contact. So that forces are known as what? Field forces. So if someone asks you what are the field forces, give some example. So what you will give? Gravitational force, magnetic fields are there, gravitational field are there, electric field is there, nuclear forces are there. This all are the examples of field forces. Now see, two types of forces. Example, if contact forces, friction and tension. Now see, friction and tension, this all concept will come in your next class, student. Friction, but in short, I'll explain you. Friction is what? Opposing force. If some object is moving and in the opposite direction, some force is applied, means some stopping force is there. Consider if a book is sliding from a slope and from the next end we are just opposing that book to stop. For stopping force, stopping force is nothing but what? Friction. Okay, then because this is due to the direct contact is there. Now that tension is also a concept where tension is always, you will learn on the, when tension is created on the surface of the water, on the soap bubbles. Okay, now if someone asks you what are the examples of field forces, so you will tell gravitational, electric, magnetic, applied, spring. This all are what? This all are the example of field forces. Now see student, we will learn about mass and inertia. Why I'm just telling all this concept to you, because when we are going to learn Newton's laws of motion, these small concepts make very important to understand that law. See, when we just mug up that laws, now it is very easy, but when you're going to understand it, what does it actually means, how does it actually come into an existence in our real life, you will know how important this Newton law is there. Okay, so first just understand these small points, then easily you will understand Newton's laws of motion. Now see student, what is mass? Mass is measurement of how difficult it is to change the object's velocity. Now see, mass is what? It is a measurement of how difficult it is to change the object's velocity. If the mass is very small, so it is a small ball, so we can easily throw that ball, right? So it will get a velocity to move. But if we get a huge iron ball, so we will not easily throw it, right? And the velocity which will come will be very small. So as the mass will increase, so velocity will become very low. And if mass is very short, so there is a change in velocity very fast. So what hence mass is what is a magic, it is a measurement of how difficult it is to change the object's velocity. Now see student, after mass there come a term inertia. Inertia is what? Resistance to change in velocity. Resistance to change in velocity word. Inertia, now the whole concept in the next coming slides I will explain you. Now just understand what is inertia. It is resistance to change in velocity. It means what? If there is a change in the velocity, the resistance occur. That term is nothing but inertia. Inertia is what? If some object is moving, right? So the tendency of the object to be in the state of rest or to be in the state of motion, that is inertia. Now you will tell me, ma'am, we don't understand anything. So right now just understand, I'm telling you the definition. In the upcoming slide, I will explain you very deeply about what do you exactly mean by inertia. So see, mass is what? A measurement of an object's inertia. Now see students, we are going to learn about Newton's laws of motions now. Now, see, before going to learn Newton's laws of motions, first I will explain you some background of Newton's laws of motion. See, can you see the photograph here? That is Sir Isaac Newton. Okay, Sir Isaac Newton's 1643 to 1727, an English scientist and a mathematician famous for his discovery of the laws of gravity, also discovered the three laws of motion. Now see, he was what? He was a great scientist and he was a great mathematician also. He has discovered law of gravity and also he has discovered three laws of motion. So today, these three laws of motion, students, today these laws are known as Newton laws of motion. The three laws of motion, now it is named as Newton's laws of motion and describe the motion of an object on the scale we experience in our everyday life. Now see, what three Newton laws of motion he has taught us. Number first, an object in motion tends to stay in motion and an object at rest tends to stay at rest unless acted upon by an unbalanced force. Second, force equals mass time acceleration, that is F equals to m into A. Third, for every action, there is an equal and opposite reaction. These three laws are termed as students Newton's laws of motion. Now, one by one, we will learn each and every law of motion, student. First, we will learn Newton's first law of motion. What is the statement of this Newton's first law of motion? An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. Now see, you tell ma'am you have just read this statement, we have not understood anything. Now see, we will go one by one. An object at rest tends to stay in at rest. Now see, if I am sitting at a rest position, so I will be in the rest position only, right? And an object in motion tends to stay in motion. Now see, when object is in motion means I have just a ball is rolling down with a constant velocity, right? So it will be in a constant velocity only unless what? Unless acted upon by an unbalanced force. Unbalanced force means when unbalance means the unequal force, not constant force, variable forces. When variable forces, if I am applying some force on that object, if I am sitting and someone just make me stand up by a force, right? So now I will not be in the state of rest because force is acting upon me. Now that ball was moving with a constant velocity. Now when I apply a force, I kick that ball with my leg, so it will move in a very high velocity. So I have acted some unbalanced force on it, I have acted some force on it, so it will also change now its motion. But when we are not applying that force, that object is rest tends to be stay at rest, and when the object is in motion tends to be stay in motion. What? Unless acted upon by an unbalanced force. If force is not applied, so they will be in their same position, they will be in their same state, right? So that statement is termed as what? This statement is known as Newton's law, first law of motion, which Newton has said us. Now see student, what does this mean? Basically, an object will keep doing what it was doing, right? What it is, students? Basically, what an object will keep doing what it was doing. It was sitting, so it will be in the rest position only. If it is moving with a constant velocity, it will move in that constant velocity. Unless, students, what? Unless acted on by an unbalanced force. When? Till force is not applied to it. If the force is applied to it, unbalanced force will apply to it, it will change its state of rest. It will change its state of motions. Okay. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving only. So it takes force to change the motion of an object. So what we learn from this Newton first of law, student, that to change their motion, to change their states, what we require a force. It takes a force to change the motion of an object. Okay, so I hope you all have understood now what the Newton's first law want to explain us, right? Now see students, Newton's first law is also called as law of inertia. Now I have told you na, that I will make you understand what do you mean by inertia. Okay, now first see, this Newton's first law of motion is also called as what, students? It is also called as law of inertia. Now what is inertia? See, the tendency of an object to resist change in its state of motion. Now see, the tendency of an object to what? To resist change in its state of motion means if he is in the state of rest, it will be in the state of rest only. If it is moving with a constant velocity, it will move in a constant velocity only. So the tendency of that object which make him to resist the what? To resist the change in its motion. If it is sitting stationary, it will be in the stationary, that tendency. If it is moving with a constant velocity, so that tendency of moving in constant velocity only. Okay, so that tendency of an object to resist change is what? To resist what? Resist means to oppose any change. Any change in its state of motion, that is known as what, student? That is known as inertia. I understood what is inertia, and same Newton law, first law is explaining us. Hence, that Newton's first law is known as law of inertia. Now you understood why Newton's first law is termed as law of inertia. I hope everyone has understood. The first law states all objects have inertia. The more mass an object has, the more inertia it has, right? अगर ज़्यादा mass है, right? So it will oppose the motion. अगर see, if there is a huge iron ball, so when I'm going to push it, it will be very hard for me. So it is resisting very high amount to change in its motion, right? वो चलने के लिए मतलब it is not ready to change its position only, so its inertia will be more. Why? Because it is resisting very high in a high amount to change in its state of motion, right? Hence the more mass on object has more inertia it has, and the harder it is to change its motion. It will be very hard to change its motion. Now see some example. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a large force to change their motion. Once they are moving, it takes a large force to stop them. Can you see a train, students? Can you see that train? The engine is just pulling a massive all the blocks which are attached to it, right? So to change their state of motion, to change their energy, to change their state of motion, a high amount of force is required by engine to change what? To change its state of rest. Now, as the engine is applying a high amount of force, so that the train will work out, the locomotive engine will go forward, and the boxes which are attached to it, high massive boxes, they will go in a same velocity as the engine is running. Now as it is having a high velocity, now if we want to stop that engine, so to stop that also large amount of force will also require, right? So when a large amount of force is required to start the motion, so large amount of force is also required to stop that motion. So how the massive things are there, the force which are required to change in its velocity, that amount of high amount of force are also required to stop that object, to minimize its velocity. Okay, now see, if we will see a flies, a bug, right, on a way to a school, this is see the above example I have taken of a massive object having a high mass. Now we will take about a small object having a very less mass. On your way to school, a bug flies into your windshield. Since the bug is so small, it has a very little inertia and exerts a very small force on your car, so small that you don't even feel it. Now see, if you're moving in your car, what you see some flies are there outside, and when this flies get strike to the windshield of your car, so you don't feel also, right? Because these flies are very small, and the inertia is also very less, hence we don't feel any force, we don't feel anything. Hence, if objects are small, inertia is less. If objects are massive, inertia is also more. Now students, we are going towards Newton's second law of motion. Now see, what is Newton's second law of motion, students? Force equals mass time acceleration, that is F equals to ma. Now see, students, we will see this second law of motion. of motion. Before going to see, we'll see acceleration. Acceleration is what? The measurement of how quickly an object is changing speed. Now see, what is acceleration? A measure of how quickly, means how smoothly, how quickly the object is changing its speed. We can also term this as rate of change of velocity with respect to time. When there is a change in velocity with respect to time, if the change in the velocity is very quick, very fast, means acceleration is very much more. If the change in the velocity is very less, in a unit time, it means the velocity, sorry, the acceleration is very low. Now see, what causes the acceleration, students? An unbalanced force causes something to accelerate. Now see, I will make you understand what is unbalanced force and balanced force also, student. See, first just go through all these points. An unbalanced force causes something to accelerate. Now see, if some forces are unbalanced, unbalanced means what? If there is a balanced force, students, the object will be in the state of rest. It will not change. But if there is an unbalanced force, there will be change in its motion. And hence, if there is change in motion, there will be change in its velocity. If there is change in its velocity, so what occurs, student? Acceleration will occur. A force can cause motion only if it is met with an unbalanced force. Force can be balanced or unbalanced, depends upon the net force acting on the object. Now you will tell me, ma'am, from when you are talking about balance, unbalanced force, but we are not getting anything. Now see, students, unbalanced force and balanced force are defined on what, student? It is defined on net forces. Now, what is net forces? The sum total and direction of all the forces acting on this object. I will explain you in the next slide each and every clear point of balance and unbalanced force. Just go to the points right now. Now see, what is net force? The sum total and direction of all forces acting on the object. And net forces always causes acceleration. Now we'll see what, see. Balanced versus unbalanced force. Now see, students, can you see the two ladies, two schoolgirls? They are pushing a box with an equal force, right? With an equal force from both the side. So will be there any change in that box? Will be there any state of motion will be there in that box? No. So net forces means the forces which are coming from both the side. Net forces is what? The sum of the forces which are applying on the object. Now what is that? Is zero. Hence, student, when there is balanced force, it causes no acceleration. अगर balance for रहा तो acceleration होगा. Why? Because the object will not move only. If it will not move, it will not accelerate. It will not cause acceleration, right? Now see, we'll see the next example here. Now see, here is one boy which is applying high amount of force, and on the other side a boy is applying very small amount of force, right? So you can see that the box will move little towards a boy which is applying small amount of force. Means when we will sum the force, we will see what? Yeah, there is some movement in the box. Box is moving from one position to another position. Means the force which are applying on both the side, they are not balanced, they are unbalanced. Hence we see what? We see there is a change in the state of that object. It is in the state of motion. It is changing its position from one place to another place. Hence, the force which are applying on it, it is unbalanced force. And that unbalanced force is what? It is giving some velocity to the object. Hence, there is a change in its velocity. The box is having what? Acceleration. Now see, if both the students When there is an unbalanced force, students, so the change in the motion will be more, and hence what, students? The change in the position of the object will be more and acceleration will be there. Hence, unbalanced force cause what? Acceleration. Always remember, unbalanced force causes what? Acceleration. Now see, after this, we are going to learn about what does F equals to ma means. Force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. The ball has a certain force. Now see, force is what? It is directly proportional to mass and acceleration. Now see, if a ball is moving with a certain acceleration, it is having some certain force, right? If force is applied, then only it is moving. Now imagine we take a ball twice as big, double the mass, but keep the acceleration constant, that is F equals to ma, says that this new ball has twice the force of the old ball. Now see, first I have taken one ball which is of 1 kg, right? It is of 1 kg, imagine. So the force will be what? Force will be 1 kg into acceleration. But if I double the mass, so force will become what? It is will be the twice the force of the old ball. So if the mass will increase, the force, high amount of force we will require to push that ball, right? So if there will be less mass, less force will require to move that ball, and if there will be the big mass, we will require more force to accelerate that mass, okay, to accelerate that object. Now imagine the original ball moving at twice the original acceleration. Now see, if it is a small ball, the previous one, now what I have done, I have throw that ball with a very high force, so the acceleration is now twice. At that situation also, we can say the ball will gain have twice the force of the ball at the original acceleration. Now see, with the help of example, you will understand this very well. Now see, small force equals to small acceleration. If we will apply small force, student, so small acceleration will be there. But if they will apply large force, अगर जोर से हमने धक्का मारा, now see, this is a toy car. If we will, I will apply it with a large force, so it will move on a very fastly, so that it will cause large acceleration. So if you push twice as hard, it accelerates twice as much. With the help of this example, you understood now what this actually means. Now see, but there is a twist. Acceleration is inversely related to mass of the object. Now see, F equals to ma, and when we take F upon m equals to a, means acceleration is inversely proportional to mass. Now if it is inversely proportional to mass, so what we can conclude, that when mass will be small, acceleration will be high, and when mass will be high, acceleration will be small. Now see, in other words, with an example, I'll explain you. If this is a large mass is there, right? So in large mass, if you're applying a force, it will go to the small acceleration. And if a small ball and the same amount of force I am applying on it, it will go to the large acceleration. Large acceleration we'll see. So with this example, we can conclude that what we conclude that when there is what student, when there is large mass, the force up and the force is applied will get a small acceleration. And when it is a small mass and the same amount of force we're applying on it, it will get a large acceleration. Now, more about F equals to ma. Now, students, see, if you double the mass, you double the force. If you double the acceleration, you double the force. What if you double the mass and the acceleration? Now, see, we have what I have explained you in the previous slide. If I'm doubling the mass, the forces get doubled. When I'm doubling the acceleration, again the force is getting doubled. What happens if I double both the mass and the acceleration? The force get quadruple 4 times. Now see, if I will double the mass 2m. Now I'm doubling the acceleration also 2a. So the force will be what? The force will be 4 quadruple. 4 times force I have to apply to that object to make it accelerate. So doubling the mass and the acceleration, it quadruples the force. Okay. Now see, what does F equals to ma says? F equals to ma basically means that force of an object comes from its mass and its acceleration. It's simple what it tells us. It tells that whatever force is coming out, it is due to its mass and acceleration. Force, now see how the force is measured. The unit of force is Newton. We write it as capital N equals to mass. SI unit is kg, acceleration SI unit is meter per second square, or we can make it as kg meter per second square. We can term as, in exam it is asked what is 1 Newton. So we can also write it as 1 Newton is equals to 1 kg meter per second square. Okay students, I hope you all have understood Newton's second law of motion also. See, in summary, I'll make you understand. The acceleration of an object is directly proportional to net force and it is inversely proportional to its mass. That F equals to ma. F stands for force, M stands for mass, and A stands for acceleration. Okay. Now we are going to learn Newton's third law of motion. What does Newton's third law of motion wants to tell us? For every action, there is equal and opposite reaction. This is the statement of Newton's third law of motion. Now, see, what does this mean? For every force acting on an object, there is an equal force acting in opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. Now see, if I'm sitting on a chair, you will say, ma'am, your no force is applying on it. That's no, students. Gravitational force is pulling me downward, and the chair is pushing with the equal amount of force me on the upward. Hence, the balance force comes into an existence on me, and I am sitting stationary. If there is a little bit of change in the force, means the gravitational force is pulling less and the seat is pushing more, so I will fly. I will not be in the state of rest, right? So there is always what students, every force have equal and opposite, for every object there is an equal force acting on its opposite direction, students. Okay, this is why you are not moving. There is a balanced force acting on you. Gravity is pulling you down and your seat is pushing you up. Okay, understood? Now think about some other example we'll take. What happens if you are standing on a skateboard or a slippery floor and push against the wall? If you are standing on a skateboard and you are pushed on the wall, what you will see, you slide in the opposite direction away from the wall because you pushed on the wall, but wall pushed back on you with an equal and opposite force. Hence, you will go in the opposite directions, right? Now see, why does it hurt so much when you stub your toe, when you hit your toe, when you stub your toe to someone? Why does it hurt? when your toe exert a force on a rock, if there is a one rock and you get stuck on a toe, you get stuck on it. So what is, students, what happened when your toe exerts a force on a rock? The rock exert an equal force back on your toe. The harder you hit your toe against it, the more force the rock exert back on your toe, and the more you get, your toe get hurts. Okay, when you get stuck. So what happened at that time when your toe is exerting force on a rock? The equal amount of force is given by rock also to your toe. So if the harder you hit, the harder you hit that rock, the same amount of force is coming back on you also, students. Hence you will get hurt more, because as harder you will get, you will give action, the same amount of reaction you will get from the rock also. Now see, force and interaction. When you push on the wall pushes on you. Look at the wall pushing on me, right? Now see, what is Newton's third of law? Newton's third law describes the relationship between two forces in an interaction. One force is called action force and the other force is called reaction force. Neither force exists without the other. Okay, they are equal in strength and opposite in direction. They occurs at the same time simultaneously. Whether I now see, it is having two forces. One is action force and second one is reaction force. If action will there, then only reaction will come. Neither force will exist without the other. If action is there, if you will say, ma'am, action is there, so reaction will not come now. No, action is there, so reaction will come. Now you tell, ma'am, reaction is coming, action is not there. No, no. If reaction is there only because when action comes. Okay, so neither force exists without the other. Now, students, these two forces are equal in strength. The strength of these forces are equal, but they are always opposite in the direction. They occur in the same time simultaneously. Now, see, we'll see some real life example. Now, see, Newton, when the girl jumps to shore, the boat moves back. Why? See, students, when the girl is jumping from a boat to a shore, so the force is exerted by a boat to a girl to action is there, but same amount the girl is exerting reaction on the opposite direction to the boat, hence the boat is moving backward, right? So with the force the girl is jumping to the shore from the boat, the same amount of with the same amount of force the boat will go in the backward direction. Now see, identify action and reaction pairs. See first example, student. When action is exert force on B, the reaction is simply B exert force on A. See, a person is driving a car. In this, what will be the action, students? Tire pushes the road. This is action. What will the reaction, student? Road pushes the tire. See, both are in opposite direction. When tire pushes the road, so it will move forward. But what is reaction? Road is pushes the tire, and then only a car is can smoothly move on a road. See in the next example, action. A boy is dropping a ball from a height, right? Action. Earth pull the ball. Earth is what? It is pulling the ball. Reaction. Ball pulls the earth. With the same amount of ball is also pulling the earth. Hence, it is going in the downward direction. In third, in rocket, you can see rocket. Rocket pushes gas. Rocket is what? It is pushing gas with a very high amount of force. With reaction, gas pushes the rocket with the same amount. This gas is pushing the rocket forward, hence the rocket is able to fly. So these are some real life example based on Newton's third law of motion. We will get a review now to all these three laws of motion, student. What was the first law? See, first law was objects in motion sorry, Now see students, what was Newton's first law? Newton first of all, object in motion tends to stay in motion and objects at rest tends to stay at rest unless acted upon by an unbalanced force. Very detailed, each and every point I have explained you what is unbalanced force, what is balanced force. If unbalanced force is acted upon an object, then only there will be change in its state of rest and state of motion. What is inertia in it? The tendency to be object to be in the state of rest or to be in the state of motion. That tendency is known as inertia. As the mass will more inertia will be more, mass will less, inertia will be less. What is Newton's second law of motion? Newton's second law of motion is force equals mass times acceleration. That is F equals to ma. If mass will double, force will double. If acceleration will double, force will double. If both will get double, mass and acceleration, force will get quadruple, right? What is Newton's third law of motion, students? We have seen Newton's third law of motion is for every action, there is equal and opposite reaction. How action force happens, how reaction force happens, everything we have seen in this session. Again, we have seen in this session, we have seen forces, contact forces, field forces. What are the examples? What are the four forces in the universe, right? Nuclear forces, electromagnetic forces, gravitation forces, weak nuclear forces. These are the four forces which we found in the universe. So these all concepts, students, today we have learned in this session. I hope you all have understood this very nicely and you have enjoyed this session. This session is for your students, for clearance of your basic concept which you are going to learn in standard 10th, and this topic will make you understand all the concepts which are in standard 9th also. So thank you very much everyone. Thank you students, thank you teachers who have attended my session. For this I am now declared to end up my session. Thank you so much.
Yes teacher, thank you so much.